Everybody, another modified competition problem from the year 2011. Now here's how I make my A's. I hope you can live with it. Um, a geometric series is connected by something called a common ratio. That's how you get from one term to the next, and the operation is multiplication. Geometric is synonymous with multiplication in this context. But notice that a over 1, just equals to a. And so that's why a would be called the common ratio. So you get from one term to the next by multiplying by a. So that would force b to be the very same as a squared. So let's write that down, and I'll go over that again in just a second. But anyway, so this series could be rewritten as 1a and a squared, based on the fact that to get from one term to the next, you have to multiply by a. So a times a, of course, is a squared. And there's a similar thing going on with arithmetic sequences where the operation is addition. But what makes this interesting problem is they share terms, but they're just in different positions. So there's two unknowns, so you would expect there to be more than one a and b that get the job done. So we're trying to find the maximum sum of a plus b here. Okay. Now this is just what I told you basically. Okay. This is exactly how we got the a squared right here. Okay. Now let's take a look at the common difference stuff. See, any pair of consecutive terms, when subtracted, give the same value. And that's what this says right here. The common difference, it's usually called D. We don't have to really explicitly say D here. We know that 36 minus B has to equal to B minus A because, again, this notion of common difference. Okay, there's a common ratio right here, common ratio, common difference right here. Okay, so we know that 36 minus B, the difference of terms 2 and 3 has to equal to the difference of terms 1 and 2. Okay? All right, but we do know also that b is equal to a squared, so we get to here pretty quickly, right? So yes. A lot of these problems end up in quadratic form, and this is no different. So what happens here? Let's see, I'll just write it like this. 0 equals to what? 2a squared. 2a squared, the minus a stays over here, and then minus 36, right? So we do have something in quadratic form. In these competition problems, almost always you end up with a factored result here. So this would be 0 equals to, if it's going to admit the nice factorization that we anticipated, it would have to look like this, right? Okay, and you know that the signs are going to have to alternate here. And so a little bit of guessing and checking, or trial and error as they call it, you would get a minus 9 right here. Okay, and then a plus 4 right here, right? Minus 9 times 4 is minus 36. Then minus 9a plus 8a gives you this minus sign that you see right here. Okay, so you see we have two circumstances here. We have a equal to, 9/2? Okay, a equals to 9/2. And y'all, by the way, this is the common ratio, and it's not common to have a common ratio that is negative, but you can. I mean, there's nothing wrong with it. You can do it, just a decreasing sequence, so a equals to -4. I got myself in trouble there. Okay, so a is equal to -4, and a is equal to 9/2. Now what about b? Remember, we're trying to maximize a plus b. We're trying to maximize this object here, a plus b. So we know what our a's are. Now, our b is equal to a squared, right? And so you would get b, remember b, here's the linkage, b is equal to a squared. So you would get, let me see if I can keep it on the screen. So you would get b is equal to 9 squared over 2 squared. What's that? 81 over 4. 81 over 4, square the numerator, square the denominator. And right here, -4 squared would be 16, right? So these are the only two possibilities. So you could have asked the question, what are the arithmetic sequences and what are the geometric sequences? And you could write them down, based on this information. But they just wanted to know, we just want to know what the maximum sum is of these values. And so we got to add them up. So if you add a plus b here, we're adding, folks, this would be what, 18/4? So that would sum up to 99/4. And let me go ahead, I'll put a plus out here. Hopefully I'm not getting too screwed up on the notation. We're doing a plus b, right? Remember that we're trying to maximize a plus b. And so what happens over here, when you add these up, you just get 12, right? Okay, so wow, this worked out pretty well. So 99/4 is a bigger number than 12, right? This number is closer to 25, right? So this would be our answer, 99/4. Okay, folks, is equal to the maximum a plus b. Like the problem, folks. It'd be interesting to see what would happen if you had 4 terms. It'd be cubic. I guess relationship be cubic. You have to deal with that, But anyway, that is the answer. The maximum value is 99, what was it, over 4? 99, excuse me, 99 divided by 4. Hope you enjoyed.